If x to 7th power, y to 2nd, z to 4th power is greater than 0, which of the following must be true? Must be true. So if we find one example for which this inequality or that is not true, it means that this inequality is not true. It's enough to find only one example for which inequality is not true. So we have given that x to 7th power, y to 2nd, z to 4th power is greater than 0. What it means? We have y to 2nd power, z to 4th power. The powers are even. What it means? That y squared is greater than 0 and z 4th is greater than 0 because the power is even. So the value of y squared and z 4th power is greater than 0. And what else? Y squared is greater than 0, but y and z can be positive or negative. Can be positive we have given this because the power is even. 2, 4. These numbers are even. It means that y to 2nd power will be greater than 0 and z to 4th power will be greater than 0. What else we have? We have x to 7th power. Because y to 2nd power and z to 4th power is positive, must be positive, so x to 7th power must be also positive because we have multiplication here. And when this expression on the left side will be less than 0, y to 2nd power is always positive, z to 4th power positive, so only x to 7th power can be negative. But because we have that this expression is greater than 0, it means that x to 7th power is greater than 0. So x to 7 is odd number. So it means that x is greater than 0. So what we have now? Let's go to first inequality. This is given. We have given that from this inequality y and z can be positive or negative. We don't know this because the power is even. So whatever we take, positive number or negative to 2nd power, you will have positive number. The same we have with z. We don't know if y and z is positive or negative from this inequality, but for sure we know that x to 7th power is positive because 7 is odd number and this expression on the left side is greater than 0. It means that x to 7th power is greater than 0, so x is greater than 0. So now let's come back to first inequality. We have that x, z is less than 0. So let me write this, that this is given. From this inequality we have that y and z can be positive or negative and x is for sure positive. And first inequality is x times z is less than 0. We have given that x is for sure greater than 0, but z can be positive or negative. If z is negative, so everything will be okay. Positive times negative give me negative number. But if z will be positive, then what will be? X times z will be greater than 0. So we see that our inequality will not be true if z is positive. So we can write that this is not true. That x times z is less than 0. The second inequality, we have x times y is less than 0. So again, what we have given? We have to always go to what we have given. We have given that x is for sure positive. And what we know about y can be positive or negative. So if y is negative, everything will be okay. Positive times negative give me negative, but y can be positive. So if y is positive, then we have that x times y will be positive. So this inequality is not true, that x times y is negative. So we can write not true. And we have last inequality, y times z is less than 0. Again, we have to come back to information which we have given. We have given that y and z can be positive or negative. So if y is positive and z negative, when we multiply positive number and negative, we will have negative. Everything will be okay. But we have given that y and z can be positive or negative. So if, for example, y is greater than 0 and z is greater than 0, then y times z will be greater than 0. So we see that our inequality that y times z is less than 0 is not true. It's enough if we show one example for which our inequality is not true. When y is positive and z is positive, then y times z is positive, not negative. So we see that our last inequality is also not true. So we can write that none of these inequalities is true. This is my solution.